Markovnikov's rule. What is Markovnikov's rule? Markovnikov's rule says that Markovnikov's rule says that in the addition of hydrogen halide to an unsymmetrical alkene, in the addition of hydrogen halide to an unsymmetrical alkene, the hydrogen is added to the olefinic carbon in the addition of hydrogen halide to an unsymmetrical alkene, the hydrogen is added to the olefinic carbon. You know how to spell olefinic? This is spelled olefinic carbon. The hydrogen is added to the olefinic carbon with more hydrogen. The hydrogen is added to the olefinic carbon with more hydrogen, while the halogen is added to the olefinic carbon with less hydrogen. I take it again. Markovnikov's rule states that in the addition of hydrogen halide to an unsymmetrical alkene, the alkene must be unsymmetrical, the hydrogen is added to the olefinic carbon. The hydrogen is added to the olefinic carbon with more hydrogen, while the halogen, which is bromine, is added to the olefinic carbon with less hydrogen. While the halogen is added to the olefinic carbon with less hydrogen, giving rise to a 2-bromo product. Giving rise to a 2-bromo product. That is Markovnikov's rule. Markovnikov's rule has only one condition. In your tests and exams, you must observe this condition. Markovnikov's rule applies to only unsymmetrical alkene. Only unsymmetrical what? Alkene. Now, what's an unsymmetrical alkene? If I have an alkene, CH2, double bond, CH2, this is called ethene. This is called ethene. Ethene is not an unsymmetrical alkene. Why? Because if you divide this structure at this double bond, what is on the left hand side is the same thing as what is on the right hand side. Since what is on the left hand side is the same thing as what is on the right hand side, it is called a symmetrical alkene. A symmetrical alkene. A symmetrical alkene is an alkene that has the same size, CH2, CH2 on the left and on the right. But let's take an example of an unsymmetrical alkene. Propene, CH3, CH, double bond, CH2. This is called propene. Propene is an example of an unsymmetrical alkene because if you divide this structure at the double bond, what is on the left hand side is CH3, CH, and what's on the right hand side is what? CH2. So this is called an unsymmetrical because left hand side is not equal to what? Right hand side. What if you're giving another structure like this? CH3, CH, double bond, CH, CH3. Is this a symmetrical or an unsymmetrical alkene? A symmetrical alkene. What if I have CH3, I have CH2, I have CH, double bond, CH2. What type of alkene is this? Unsymmetrical alkene, isn't it? It means that which of these alkenes, let's say this is A and this is B, which of these alkenes will yield the product according to Markovnikov? Is it A or B? B. Markovnikov's rule applies to only unsymmetrical what? Alkene. If you don't see that the alkene is not unsymmetrical, it means the reaction will yield no products. Are you following? So, let's take a typical example of Markovnikov's reaction. Let's take an example. Nobody bothered to ask.
I need to ask you something.
What is olefinic carbon? What is olefinic carbon? Olefinic carbon are, this is not olefinic carbon, are the two carbon having the double bond. The two carbon atoms having the double bond is called olefinic carbon. Yes?
So this propene, if you have to name something like this, can't you call it propene?
Yes, you can say propane in one propene or just propene. In organic chemistry, whenever the double bond is at carbon 1, we don't specify it. It's just like a match. You don't say one X, you just say X. So instead of saying one propene, just say propene. We know that the double bond is at carbon 1. So what's an olefinic carbon? An olefinic carbon are the two carbon atoms having the double bond. In this structure, CH3, CH, double bond, CH2. These two carbon atoms having the double bonds are referred to as olefinic carbons. They are referred to as olefinic carbons. The two carbon atoms having the double bond are called olefinic carbon, and that is where they add either the hydrogen or the halogen. All right, according to Markovnikov's. Now, the carbon, remember, please listen up. I said the two carbon atoms having the double bond are called olefinic carbon, but the carbon before the carbon having the double bond, this carbon that is before this carbon having the double bond is called allylic carbon. Allylic, yes. Allylic, meaning it is close. It is the carbon. Allylic means next to. Alright? Allylic carbon is the carbon that is next to the carbon having the double bond. Allylic carbon. Alright? The carbon next to the carbon having the double bond. Some textbooks refer to it as alpha carbon. Okay? Allylic carbon is the carbon next to the carbon having the what? Double bond. There's something they call allylic substitution. Allylic substitution means what the carbon you're substituting is this carbon goes to the carbon having the what? Double bond. Olefinic carbon and the two carbons having the double bond. Allylic carbon is the carbon next to the carbon having the double bond. So let's look at Markovnikov's reaction. Markovnikov's reaction, let's have an unsymmetrical alkene. We said Markovnikov was only proceed in or with an unsymmetrical alkene. This is an unsymmetrical alkene. If I pass this alkene through hydrogen bromide, please note, Markovnikov's rule does not have a catalyst. Markovnikov's rule is the only reaction of alkene that does not have a what? Catalyst. Yes, anti-Markovnikov has a catalyst. It's not Markovnikov, it's opposite. Alright? Markovnikov has a catalyst, but anti-Markovnikov. Markovnikov does not have a catalyst. Alright? Markovnikov does not have a catalyst. Anti-Markovnikov is the opposite of Markovnikov. You're going to look at it. So we are adding hydrogen bromide to this. From the statement of Markovnikov, he's saying that between these two carbon atoms, this carbon is having two hydrogen. This carbon is having one hydrogen. This carbon and this carbon are called the olefinic ones. Carbon. This olefinic carbon is having one hydrogen. This olefinic carbon is having how many hydrogen? Two hydrogen. So Markovnikov is saying, in this hydrogen bromide that you are adding to this compound, add the hydrogen to the olefinic carbon having more, and add the halogen to the olefinic carbon having less. Since you are adding, it will break this double bond to single bond. Markovnikov is saying, the carbon having more hydrogen, add extra hydrogen to it, and the carbon having less hydrogen, add bromine to it. So if you do that, we are adding hydrogen to this carbon, and we are adding the halogen to this other carbon. Alright? Building the product CH3 to CH, I'm adding halogen to this carbon. So I have Br, this is the halogen. It breaks, since an addition reaction, it breaks this double bond to single bond. And if I'm adding hydrogen to CH2, I will have what? CH3. So this is a 2-bromopropane. 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 This is Markovnikov's reaction. This is Markovnikov's reaction. Alright? Do we understand?
Yes, sir.
Zoe, do you understand? Where don't you understand? This part, bromo is added to the carbon, having one hydrogen. Hydrogen is added to the carbon, having two hydrogen. The addition is always between the two carbon atoms having the double bond. So you understand this part. Hydrogen is added to this, bromine is added to this, reducing double bond to what? Single bond. The name 2,2-bromopropane.
Okay, so the hydrogen is added to the carbon with the highest number of
yes, just say hydrogen is added to the carbon with two. Hydrogen is added to the carbon with two hydrogen atoms, and halogen is added to the carbon with one hydrogen. That's Markovnikov's. No matter how you twist it, you must see this in your exams and tests. Reaction equation A, equation B. For equation A, what will be the product? Why? Because it's what? Unsymmetrical. Very good. So it means for this one, the product will be no what? Reaction. Do you know why it's no reaction? Because this alkene is what? A symmetrical alkene. And symmetrical alkene does not give any products in Markovnikov's rule. It must be what? Unsymmetrical. This one will give us a product. Now, what will be the product? From Markovnikov's rule, what will be the product? Hydrogen will be added to this carbon, having more hydrogen. Isn't it? And halogen will be added to the carbon, having what? Less. Giving rise to CH3, CH2, CH. Here we have what? Br, bromo. And if you add hydrogen to CH2, it will reduce this double bond to single bond and you have what? CH3. Please take note, not all alkenes yield products according to Markovnikov. The condition for Markovnikov is that the alkene must be what? Unsymmetrical. Alright? So let's look at anti-Markovnikov. Anti-Markovnikov. Anti-Markovnikov's reaction. Anti-Markovnikov's reaction. Anti-Markovnikov's reaction is the opposite of Markovnikov's, and it occurs in the presence of a peroxide. Now look at this. If I have an unsymmetrical alkene, now I want to ask you a question. If Markovnikov, alright, in Markovnikov's reaction, there is no catalysis, there is no peroxide. But in anti-Markovnikov's, there is a peroxide. The common peroxide we use is called hydrogen peroxide, H2O2. Alright? We can use other peroxides, sodium peroxide, potassium peroxide. But the common one is hydrogen what? Peroxide. Alright? Now, if Markovnikov's reaction must be with unsymmetrical, anti-Markovnikov, will it proceed with unsymmetrical or symmetrical? Unsymmetrical. Both Markovnikov's and anti-Markovnikov must be what? Unsymmetrical alkene. Please take note. Both Markovnikov's and anti-Markovnikov's reaction can only proceed with an unsymmetrical what? Alkene. If this alkene happens to be a symmetrical alkene, there will be no reaction. Please take note, very important. Markovnikov proceeds, whether Markovnikov or anti-Markovnikov, it must only proceed with unsymmetrical what? Alkene. Now, Markovnikov does not have a peroxide. Anti-Markovnikov occurs in the presence of a what? Peroxide. Now, what happens here? The addition is between these two olefinic carbon. Okay? In Markovnikov, hydrogen is added to the carbon with more hydrogen, and the halogen is added to the carbon with less hydrogen. But in the case of anti-Markovnikov, it's the opposite. The hydrogen now will be added to the carbon with less, and the halogen will be added to the carbon with what? More. In Markovnikov, what we said in Markovnikov is that the hydrogen will be added to this carbon with 2 hydrogen, and the halogen will be added to this carbon with what? 1 hydrogen. But in anti-Markovnikov, now it's opposite, the other way around. Hydrogen now will be added to the carbon with less, and halogen will be added to the carbon with what? More hydrogen. So if we do that, we'll have this as CH3, we'll have this as CH2, because this is anti-Markovnikov now. Hydrogen now will be added to the carbon with less hydrogen. Hydrogen will be added to the carbon with less hydrogen. In anti-Markovnikov will be added to the carbon with less hydrogen, and the halogen bromine will be added to the carbon with what? More hydrogen. So that it will break this double bond towards single bond. So I have here, I have what? CH2, and I have what? Br. This is called 1-bromopropane, or you can call it bromopropane. This is called a bromopropane. It's like you say bromopropane, or you can say 1-bromopropane. Okay? Bromopropane. If you observe in anti-Markovnikov products is a bromopropane. But Markovnikov is 2. Markovnikov is always a 2-bromo. Alright? But anti-Markovnikov is just a 1-bromo. Are you following? Anti-Markovnikov is the opposite of Markovnikov, and it occurs in the presence of a what? Peroxide. Whenever you see a peroxide and hydrogen bromide, know that it is anti-what? Markovnikov. Are we following? Okay. Yes.
Because it looks like the pentane. Or pentene.
Pentane.
No, not pentane. Pentane. So, what is it? Not to be 2 bromo, so like 3 bromo.
Let me see. Like pentane.
Yes, pentene.
CH3, CH2, CH. 1, 2, 3.
CH. And then
CH. And 1, 2, 2 in.
Yes.
Something like this. Okay, let me ask you now. Look at this first of all. We need to proceed according to Markovnikov. This is a very important question. Pentane. Will it proceed?
No.
If you have pentane and you're reacting it with hydrogen bromide, here these two olefinic carbon, they have one hydrogen, isn't it?
Yes.
But are they unsymmetrical?
Yes.
Are they unsymmetrical? Yes. They are unsymmetrical because what's on the left hand side is not equal to what's on the what? Right hand side. But they are not having hydrogen, 1. This will not give us a Markovnikov product. Why? Because the olefinic carbon, this is a major product, this is a major alkene. They call it a primary alkene product. Because according to Sachs, this carbon and this carbon are having 1 hydrogen. Markovnikov's will proceed when the carbon, the defining carbon, are having an equal number of hydrogen. That is why all your tests and exam questions, the one they use is always propene.
So
Propene is a very propene among the team. You get propene among the team. And the ones they always use because the two olefinic carbons are having 1 and 2 hydrogen atoms. But from pent, hex, the olefinic carbon can be at position 2, can be at position 3. Do you get? From pent, hex, hex. It can be rotated between 2 and 3, and it will give you CH. The most the alkane they always use is always propene, See, let me give you a secret. Most of the reactions of alkene, they always use propene and ethene. Propene and ethene. They don't go down to butene. They use propene and ethene.
Function.
Most of the reactions in your exams and tests,
Alkenes.
alkenes. That's what they do. Even for alkynes, they use ethyne. They don't even use propane, they use ethyne. So they're always concerned with ethene, propene, ethene. So if you know that this one I'm always using is propene, so that when you see something like this, you won't forget it.